Warm greetings. The South African Mathematics Foundation, whose website address is www.samf.ac.za, administers a number of competitions for high school learners, both junior and senior, annually. Amongst the competitions are the South African Mathematics Olympiad for juniors and seniors, and each one consists of 3 rounds. Another competition that the foundation administers is the team competitions, and that's also done on an annual basis, 1 team competition each year, and on average over 50 teams of 10 participate in both the junior and the senior competitions. The team competitions has 2 parts to it, the individual and the team. The individual papers are tackled by learners on their own, while the team papers, they can merge with the teams of the team mates, 10 to a team, to solve those 10 problems that are assigned each year. Okay, with those introductory remarks, we want to say that this whole program is part of a multi-program series where we try to unpack all the solutions of all these competitions that are held in the years 2020, 2023, 2024, and 2025. Today, we are going to look at the 2025 individual paper. As you can see, it's the 2025 individual, and we will now look at question 1 in this paper. Okay, I've been having problems with sorry, just please be a little bit patient. I've been having problems with my writing pad here, and it seems to me that there is no end to this. Okay. It's all right. I seem to have got the first question. Hopefully, I don't have any further problems during the course of the game, during the course of this presentation. All right, question 1 says, Alex and Bonolo play a game. Both players start with 10 points. In each round, the winner receives 3 extra points, while the other player loses 1 point. The game ends with Alex and Bonolo having 40 and 16 points, respectively. How many rounds were played? All right, so we don't know how many rounds were played, but in each round, there is there's a winner and there's a loser as well. must apologize for this. My writing pad is playing havoc with me. Let's hope this thing works out now. Okay, so I think we're probably on our way now. Thanks for the patience. So the way we understand this, there are two players, and the winner gets 3 points, or the loser loses 1 point. Okay, and at the end of the game, they both have 40 points and 16 points, respectively. The question is, how many rounds were played? Okay, the quick way of doing this is that at each game, if one wins, one increases by 3 and the other decreases by 1, it means that there is an overall increase of 2 points in each round. Okay, so there is an overall increase of 2 points in each round. Now, altogether, they had 56 points. At the end, they have together 56 points. They started with 10 points each, right? Okay, so the points scored during play is 56 minus 20, because they started off to 10 free points. That makes 36. Okay, so therefore, there are those 36 points were scored, and each round contributed 2 points to the overall total. So therefore, there are 18 rounds altogether. Okay, that's one way of doing it. And maybe there's another way. Let me try to figure out the other way. In this case, you give a name to the number of games that one of them actually won. So suppose, suppose Alex won X games or X rounds, and Y and Bonolo won Y rounds. Okay, so we suppose that these people won. Those two players won X and Y rounds, respectively. Now, you have to remember that a win counts for 3 points. So we can count how many points Alex had at the end. So Alex's final points are, it says here that Alex and Bonolo won 40 and 16 respectively. So Alex was 40. Now, how did he accumulate that 40? He started off with 10. He won X. So each time he won, he got 3 points. So those X wins counted for 3X. And he lost Y because Bonolo won Y. So he lost Y. And for each of those Ys, he lost a single point. So that's how he accumulated his 40 points. And similarly, the other guy, he won Y, so it was 3Y minus X. All right. And the problem is to find out what is X plus Y. In other words, how many rounds were played altogether. If Alex won X rounds, the other rounds, Bonolo would have won. So altogether, it's X plus Y. I think if I add these two, 56, 20, 3X minus X is 2X, 3Y minus Y is 2Y, and this is adding. Then if you bring this 20 to the other side, you get 36, and that gives you, again, X plus Y is 36 over 2, which is 18. So you could have used symbols to calculate your two equations and two unknowns and solve. All right. But I think the first one is far more elegant. And I'm sure you will agree with that. Okay. I usually write down the solutions in advance so that you can have a look at the written solutions. And at the same time, it gives me a chance to check to see if I went off anywhere. So here we go. You see at the end of this, you got X is equal to 18, which is the number of, well, in this case, X is the total number of rounds. This is the first solution that I gave. Okay. So let's just get on to the question 2. Question 2 says, you got 5 numbers here, and they want to know which is the largest. Obviously, you're not allowed to use a calculator, so you have a you got a lot of things here which you can't calculate. Well, for one thing, I can calculate. 2025 was a popular year because it was a square year, so that is 45. This is slightly more because you got 45 plus something, right? So we want to know which is the largest, so you can eliminate that guy. And here you got square root of, oh, this is also greater. This is greater than square root of 2025. Right? Because you're adding something to this. So you can eliminate this is actually square root of 2095, 45. So square root of 25, 2025 is 45. So it's like this. So again, it's less than 46. Square root of, even you can see it's less than 50. Okay. But this last one here is of interest. You see, this is 45 here. and this you move it 4 places, so it's 4.5. It's 45 times 4.5, and this is greater than 180. 45 times 4 is greater than 180. So this is a likely candidate. You can see this one here is smaller than square root of 2025 because you're subtracting. So you can eliminate this one. This is just slightly more than, this is very, very much larger. So this is the answer. And the others cannot compare with it. Okay, I think that's a silly kind of a question. Let's get on to, if you look at the solutions, yeah, we have some kind of an argument which eventually leads to the same end result. Okay, so let's get on to the next question. And 3. Find the remainder when 7 to the power of 2025. Oh, this 7 times 7 times 7 multiplied by 2025 times. That's a huge number. When that is divided by 100, what is the remainder? All right. Now, when you divide anything by 100, the remainder is very easy to see. Like, for instance, if you take some number, say 3, 5, 8, 9, you divide it by 100, you can see this is equal to 35, remainder 89. This is 3500 plus 89. Right. So the remainder is just the last 2 digits. When you're dividing by 100. But the problem is now you've got this very big number. You've got 7 to the 1. I just want to see what if there's a pattern here. 7 squared is 49. 7 cubed is 343. So the remainder here is 49. Here the remainder is 43. And 7 to the power of 4 is 2,401. The remainder is 1. So that is very attractive. The reason why it's attractive is that this is 2,400 plus 1. Now, if you take any 2 numbers, let's call it 100A plus a remainder R, this is the 2-digit number, and you multiply it by another number where S, we don't know about A and B, but certainly R and S are 2-digit numbers, right? If you expand this, you'll see that you got 100 times 100 as a coefficient. In the middle, you got 100 BR, and you get another 100 AS. So the 3 terms is as 100 is the common factor. So you can say that this is a 100C plus RS. So if you multiply 2 numbers, the remainder, you see, this is a multiple of 100. So RS is the remainder when you multiply R and S. So you really need to multiply R and S, but provided if RS is a 2-digit number, if RS, R times S is a 2-digit number, then RS is the remainder. All right, when you multiply two numbers like this. So what does this say? It tells me that, for instance, if I multiply, I had the 7 to the power of 4 is 2,401. So when you multiply 7 to the power of 4 times 7 to the power of 4, you're going to get 100. Well, it's 2,400. I'm just going to put A plus 1 times 100A, B plus 1. It's actually A plus 1. But now here you got R and S are 1, you see. So in this case, the RS is 1. In fact, if you multiply the next one, you'll still get 1 times 1. Because if you multiply this thing any number of times, you can see that you're going to get 7 to the 4 times 7 to the 4 times 7 to the 4, any number of times, right? The remainder is always, you'll have 1 times 1 times 1, and that is always equal to 1. Okay, so that's a great help because you can see that all you have to do is 7 to the power of 4 times 7 to the power of 4. These are multiples of 4. Let me be more, a little bit clearer. So in short, you have that 7 to the power of 4 to any power, right? The remainder is 1. Okay, so you need to take, and this is 7 to the 4n. So you look at the multiples of 4 in 2025. So you'll see how many 4s are there in 2025. And you'll see that the remainder, when you divide by 4, is 1. Therefore, 2024 is a multiple of 4. Well, we could have said that the last two digits must be a multiple of 4. So in particular, you've got that 7 to the power of 2024, right? Ends in, is of this form here, dot, 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 and the last two digits are 0 and 1, okay? So we are interested in 7 to the power of 2005, so you have to multiply this by 7. 7 times this is 7 to the 2005. When you multiply this by 7, you will definitely end in 07. And as we said earlier on, these last two digits is the remainder. So the answer is 7. Because the last two digits of a number is the remainder when that number is divided by 100. So that's the answer. Okay. So that takes us to the next problem. Let me just see the solution that I had prepared in advance. Okay, I've got some explanation there. You can read that and see whether you can make head or tail out of that. So let's go on to question 4 now. Question 4, you've got a diagram here. It says that the cells of the triangle in the figure are filled with numbers. So you've got numbers all over the place here. Each number, excluding the numbers in the bottom row, is equals the sum of the two numbers immediately below it. So if I take this number here, this is the sum of the two numbers. When you add these two, you will get that. Every number, like to get 21, these two add up to get 21. And those two add up to get 75. Okay. They say find the value of x if the sum of the numbers in the bottom row, so all the numbers here, if they add up to 19. Okay, we don't know what these numbers are. In fact, there are lots of unknown numbers here. You are given only two numbers. Okay, let's see what we can make out of this. So we don't know what these numbers are. We'll call them A, B, C, and D. So you got 5 unknowns. But we do know that A plus B plus X plus C plus D, they say that the sum of the numbers in the bottom row, right? I've got all the numbers here, is 19. Oh. All right, let's call these numbers here E, F, G, H. All right, now remember, E is A plus B. Right? And H is C plus D. So you can say that E plus X plus H is 19. All right? So E plus H is 19 minus X. So when I add these two, I get 19 minus X. But remember that F plus G is 21. So therefore, E plus F plus G plus H, the E plus H is 19 minus X, and F plus G, according to our rule, is 21. And that gives you 40 minus X. All right, so we know the sum of the numbers in the third row or the fourth row in terms of X. Okay, now let's just go on. Let's call this A and B. No, we already got A and B. Let's call this M and N here. Now remember, M is E plus F. So this E plus F is M. And N is G plus H. So this is N. So in fact, what I have here is M plus N. On the left-hand side is 40 minus X. All right. So these two together add up to 40 minus X. So we can say that the sum of the numbers in this row here is 40 minus X plus 61, plus 21. Okay, but I'll just hold on with that. Now let's call this one here P and Q. All right, now what is P plus Q? P plus Q on the one hand is 75 if you go upstairs, but P plus Q is also, it's M plus 21 that's P, and Q is N plus 21. If you add up all these, you get M plus N plus 42. But if you got M plus N is 40 minus X. This is 40 minus X. So therefore, you got 40 plus 42, which is 82 minus X. And we said that this is 75. P plus Q is 75. All right. So there it is. You've got your equation in x, and you can solve. It's 82 minus 75, and that is 7. All right, so you see, the moral from the story is that don't be intimidated with so many unknowns. We've got, as you see, we've got a number of unknowns, yeah? But we just proceeded systematically from the unknowns, and each time we replaced the known quantities and kept climbing up like that, right? And eventually you can get to the answer. So we say that x is equal to 7. Right, so that is the answer to this question. You can see it's very similar to what I've said so far. All right, let's get on to the next question. It's question 5. Question 5 says the following. You got two triangles and they are similar. Similar means they've got the same angles and therefore their sides are in the same proportion. All right, we've seen many of these. Let's draw these triangles. One is ABC. They've got the same angles. And then you have maybe a smaller triangle. Okay. Now they give you the areas, and the question is all about the sides. So let's we know the sides are in the same proportion because they are similar. You see, what does that mean? It means that if I call these, let's call this ABC, and this is DEF. So normally we call the side opposite angle A, call it small a, small b, small c. This it's just a convention. I like to stick to that. And now this is similar. So there is a proportionality factor. So let K be the proportional factor. I don't know whether this is the name for it, but I call it proportionality factor. So in other words, you have to multiply each of these sides by the single number K to get to the other triangle. See, in practice, it's actually this over this equals this over this equals this over this. That ratio, if I call it K, then you see that this is what I've got. Now, the area of DEF is 63. The area of ABC is 175. So let me put 175 inside. And inside here, I put 63. That's the area. Now, interestingly, the area, if your proportionality factor is K, if the sides are in the ratio K, then the areas are in the ratio K squared. This is a very useful fact. The areas are in the ratio K squared. If you want to know why, if you take, for instance, now, we got this is CK. So you can say area DEF over area ABC. I claim that this is K squared. Right. It's easy to prove because you use a trig formula. In trigonometry, the area of a triangle, there's a formula for it. It's half the product of two sides. Let's take these two sides, CK, KC, KB, times the sine of the angle between them. That's sine D. Right? So it's half that times the two adjacent sides times the included angle. And the area of ABC is half BC sine A. And this area here is half BC sine A, the same formula. But remember, angles D and A are the same. Therefore, the sines are the same. The halves cancel. And you got BC at the top. There's a C there, and there's a B there. And the only survivors are K and K. So this is equal to K squared. Right, as we said. So it means now that DEF is 63. That area was given over 175. That's equal to K squared. Now you can simplify this. 7 goes into both of them. 7 times 9, 7 times 25, and that is K squared. So K is a nice number. The square root. So K is 3/5. Okay, so we've got what the proportionality factor is. Now, the question is, let's proceed with this. It says that the BC plus EF is 10. I'm going to put 10 in the left-hand side. BC plus EF. Now let's look at my picture. BC is A, and EF is AK. That's BC plus EF. You can take out A into 1 plus K. Okay. A is a common factor. And K is 3/5. So 1 plus 3/5 is 8/5. So this is 8A/5. And that's exactly, we needed to calculate BC. So BC is equal to A. So we need to calculate A. Now you can see this 8A/5 equals 10. It was on the left-hand side. I'm putting it to the side. Right here, you got you can solve for A. Multiply by 5 on both sides. 8A is equal to 50. And divide by 8. And you get 25/4. 50/8. So 6,25. Square. And the units are centimeters. So BC is actually 6,25 centimeters. So this is a application of similar triangles. They have the same angles and the sides are in proportion. And we've shown that the areas, one area over the other is not K, but K squared, if K is a proportionality factor. I have to put this over this, DEF, because I got the K's here, you see. All right, so the answer is 6 1/4. There it is. You have at the end 25/4, which is the same as what I've given it. And you can study my solution. Okay, we go on to question 6 now. So in the figure above, a rectangle is split into four smaller rectangular pieces. As you can see, the perimeters of the three smallest pieces are 14, 18, and 18. Okay, so we don't know, this is shaded here. The three smallest ones are 14, that's the very smallest. This is 18, and this is also 18. These are the perimeters. So you want to know, evidently, determine the perimeter of the shaded rectangle. Right, okay, so that's what we need to do. Okay, so let's give the perimeter of the shaded rectangle is twice 2 into length plus breadth. So we can call this A, we call this B. So we need to calculate what is 2 into A plus B. That is the question, because you need to calculate the perimeter of this. Okay, I've got B here. Let me put this to be C here, and I'll call this D, because I can get some equations now. See, I've got C and D here. Now C plus D, for instance, C plus D is half the perimeter. The perimeter is 14. C plus D, twice into C plus D is 14. So C plus D is 7. So like that, you got C plus B is 9 here. If you look at this, I want to write down these equations because I need to get to that. And here, I've got A plus D. Is 9. This is D here. It's not written very nicely. Let me just make this. All right, so the question is, what is 2 into A plus B? Well, you've got three equations here. How are you going to get A plus B now? Now, often we've seen some of these things before. And a good trick is to add all these known equations. So if you add, you got C plus C is 2C. Let's take that off. Plus D, or 2D. And then you got plus A, plus B. If you add up all these things, 9 plus 9 is 18, 25. All right. So we needed to calculate A plus B. Okay, so A plus B, well, 2 into A plus B. Well, let's work out A plus B. A plus B is 25. If you take the other side, I'm going to put minus 2 into C plus D, because this is really 2 into C plus D. But we have C plus D is 7, you see. All right, so this is 25 minus 2 times 7 is 14. That is 11. So we needed 2 into A plus B. That's the perimeter of the shaded region, is 2 times 11, which is 22. So that's the answer. So the perimeter of the shaded region is 2 into length plus breadth. Okay, so that is the solution to that problem. Let me just check to see whether I got the same answer. Oh, okay. So you got 22 again. All right.